Hello, everybody. My name is Ana Cañizares. I'm a radio amateur. My call sign is Echo India 5, India X-Ray Bravo, and I work in Technological University, Dublin. I welcome you all to this event where we are going to have the privilege to watch the students that are here with me have a direct contact using amateur radio with the International Space Agency, the International Space Station. Now, to let all of the people that is watching know what this is all about, we are gonna give pass to a series of slides and videos that will teach you a bit more about what is the ISS and how are we gonna contact it. Thank you very much. Plus project. Today, students from 9 of our Tri-5 schools will have the chance to speak live to an astronaut aboard the ISS thanks to amateur radio in the International Space Station. But what is ARIS? The ARIS program was created and is managed by an international consortium of amateur radio organizations and space agencies. This includes the European Space Agency in Europe, the Japan Aeronautics Exploration Space Agency in Japan, Roscosmos in Russia, the Canadian Space Agency in Canada, and the National Aeronautics and Space Administration in the USA. Amateur radio on the International Space Station allows students and educators across the globe to communicate with astronauts on the International Space Station using amateur radio. This program aims to inspire and engage students in science, technology, engineering, and maths, STEM, by providing them with a unique opportunity to learn about space and engage with astronauts. So what exactly is the International Space Station? Let's learn about it in this video from NASA JPL.
The International Space Station isn't just a symbol. It's a powerhouse of cutting-edge science, constantly revealing secrets that defy Earth's limitations and drive us farther into the cosmos.
Our mission is research and science. We have experiments mounted on the outside of the station that are looking at Earth. We study our own bodies and how they react to space, to weightlessness, to radiation, and that helps not only us go on further in future missions, but also helps for medical research back home. And then we study lots of different things as well, like materials, combustion, all sorts of things that help us understand life back on Earth.
Yeah!
Microgravity doesn't play by the rules. It flips them upside down, transforming how liquids flow, how flames burn, and unraveling biological mysteries before our eyes.
I saw some heart tissues beating in space, and it was incredible.
Sultan, we see that top one beating. Looks like happy heart cells.
But we're not just along for the ride. We're explorers, diving headfirst into the challenge and harnessing the power of this unparalleled platform, just as we have been for decades. We're on a relentless quest for answers, seeking to understand the intricate workings of the human body in space and ensuring future crews stay safe on their daring journeys beyond Earth's orbit.
The human aspect of human space exploration is always going to be very important for decades to come.
And when it comes to technology, we're not waiting around. We're discovering new ways to grow crops in harsh environments and engineering innovations to tackle Earth's greatest challenges.
We have amazing technology that allows us to recycle water and create water for us to drink. It's delicious.
Microgravity isn't just a curiosity. It's a game changer in the fight against diseases back on Earth, paving the way for breakthroughs that benefit us all and enabling new economic opportunities in space.
Welcome Axiom 3 on board the International Space Station.
From our vantage point more than 200 miles above Earth, we are not just spectators. We're gaining unprecedented insights into the world we call home, and we're sharing our findings openly. We're not just achieving results today. We're sparking inspiration in future generations of explorers and embracing the power of global collaboration as we reach for the stars.
What was your favorite experiment on the International Space Station?
Toby, great question. My favorite experiment was the one that I got to eat. It was us growing hatch chili peppers in our plant habitat.
Station Huntsville on 2, we have video in Node 1. Look at those chili peppers.
And as we soar through space at 17,500 miles per hour, each moment is a step closer to unlocking the mysteries of our Earth, our universe, and propelling our pioneering spirit even farther into space. So come along for the ride aboard the International Space Station.
The first section of the ISS was launched in 1998, and it will take 41 more launches to complete the original shape of the station. Since then, this fabulous international research facility has kept growing over the years, with further launches and missions adding more modules, solar panels, radiators and support trusses, among other things. In its current configuration, the ISS has a length of more than 100 meters, longer than a football pitch, and still, it's able to orbit at 400 kilometers above the Earth's surface, completing a full turn of the planet every 90 minutes. The ISS orbits Earth at 28,000 kilometers per hour and approximately 400 kilometers altitude. This is what is called a low Earth orbit. The orbit has an inclination of 51 degrees, which allows the ISS to cover most of the planet while orbiting, because the planet rotates as the ISS orbits. In this low Earth orbit, the ISS is still within the pull of the gravitational forces of Earth. The microgravity environment is produced because of the balance between the gravitational forces pulling the ISS and everything inside it towards the Earth, and the centrifugal force pulling everything in the opposite direction due to the station orbital motion. As previously mentioned, Earth rotates at the same time as the ISS is orbiting, so the ISS can cover most of Earth during its passes. Each pass, each turn around the Earth, takes the ISS about 90 minutes to complete. So the space station completes 60 full turns around Earth every day. So, with the ISS traveling so fast, how can we know where it is? We can use tracking programs, phone apps, or websites like this one, called Spot the Station. They use telemetry data transmitted from the ISS, location information, to create a visual map and allow us to figure out where the station is at any given moment. In this map, the orbit of the ISS is represented as a curve and allows us to estimate where the station will be. We will be using a map like this one to track the ISS for our contact today, which comes from representing in 2 dimensions a 3-dimensional orbit of the station. We can see what this looks like in this unfolding image. Let's go back to the ISS. We have mentioned that the ISS transmits information to Earth, because it will be very silly to have such a complex and expensive lab orbiting Earth and not being able to talk to the people in it. So, how does the ISS communicate? The ISS uses different radio frequencies to communicate with Earth, much like the Wi-Fi in your phone, Bluetooth, or a walkie-talkie. Radio waves are a type of electromagnetic radiation created as a result of vibrations between an electric field and a magnetic field. They travel at the speed of light, which is also a type of electromagnetic radiation. And this means that we can communicate with the ISS almost instantly, but it will take our signal a bit more than a second to reach the moon because it's farther. In less than an hour, we will attempt to communicate directly with an astronaut aboard the ISS, or transceiver to the Earth using amateur radio, which is generally the only way that the general public is able to reach the ISS. And what is exactly amateur radio, you ask? Amateur radio, also known as ham radio in some places, is the use of the radio frequency spectrum for purposes of non-commercial exchange of messages, wireless experimentation, self-training, private recreation, radio sport, contesting, and emergency communications. The term amateur is used to specify a duly authorized person interested in radio with a purely personal aim and without pecuniary interest, meaning we don't do this for money or for a reward. You will have heard me say at the beginning of this session that my call sign is Echo India 5, India X-Ray Bravo. This call sign identifies me as a licensed amateur, so it will tell others when I am communicating with them that I have passed an exam and obtained a license that gives me permission to transmit and receive in certain frequencies in a safely manner. Many astronauts, but not all of them, are also radio amateurs, and those are the ones we can communicate with. Why do we need to pass an exam though? One of the reasons is because improper use of the radio spectrum can cause interference with other services that also use the radio spectrum to communicate, such as planes, phones, police, ambulance, etc. Radio amateurs are trained to ensure that they know how to operate safely and without causing any problems. What do we need to talk to the ISS? We will need a radio station on Earth that is connected to an antenna that is able to transmit and receive the radio signals. So, we're going to set up a temporary radio ground station on the top of the Central Quad building in Technological University Dublin in the Grange Gorman campus. This station, which will work a bit like the Columbus ground station in Germany, but much less sophisticated, will have an antenna that can track the ISS as it is moving in the sky to ensure that we can send and receive the clearest of signals. And the ISS will also need a radio that can communicate in the same frequency as ours, and they have not one but two on board. The ISS has been fitted with two Kenwood radios. One of these is located in the Russian section of the ISS, while the other one is located in the Columbus module. Both radios transmit and receive in between 144 to 146 MHz, what we commonly call the 2-meter band in amateur radio. This frequency is considered VHF, very high frequency, and the waves in this frequency propagate mainly in a straight line, requiring a clear line of sight as obstacles can block the signals. The advantage of contacting the ISS using VHF is that there are generally no obstacles between us and the station. Because we will communicate directly using VHF, we will need to wait until the ISS is within range of our station, which we will be able to know using our tracking software. On the left, you can see what the ISS radio looks like, and on the right, the type of transceiver that we will be using in Technological University Dublin to carry out this ARIS contact. This radio will be connected to an antenna that can follow the orbit of the ISS in real time to ensure that we get the best signal possible. Back to our tracker. As we mentioned, we will need to wait until the ISS is within range of our station, which we will be able to tell using our tracking software or the website Spot the Station. We will know that we are in reach of the ISS when the green circle in the map, which indicates how far the ISS is from the horizon at our location, starts overlapping with our position. A bit before that, we will start calling the station. Once we acquire the signal, we will have about 11 minutes to ask our questions before the ISS disappears again over the horizon. So now we know how we can communicate with the ISS, but who are we talking to? Let's learn about the radio amateur we will be talking to in the next slide. Takuya Onishi is a Japanese astronaut, member of Crew 10 and current commander of the ISS. His call sign is Kilo Foxtrot 5 Lima Kilo Sierra, but he will be using the station's call sign, which is Oscar Romeo 4 India Sierra Sierra, and we will be using a special call sign in TU Dublin, which is Echo India 1 India Sierra Sierra, to call him back. Let's learn a bit more about him.
When people are born, they naturally want to explore their environment. That's how we expand our world, and that's how we find something new, advance our technology and civilization. My name is Takuya Onishi, and I am a mission specialist for NASA's SpaceX Crew 10 mission to the International Space Station. I was born in Tokyo, in Japan, and I grew up mostly in the west part of Japan. My family moved our locations so often, so that experience actually helped me to get used to a new environment quickly and comfortably. I have always been interested in space since my childhood, but I never thought I would actually become an astronaut. I chose to become a pilot. I think I was very lucky because the experiences as a pilot of a commercial airplane really helped me to go through astronaut selection process. Space is hard, very challenging, sometimes unpredictable, and there is no 100% guarantee of success. And that's why I think cooperation is the key to success. Each country, each crew member, each agency, each company brings its own expertise and its strengths in order to be able to cooperate as a team. And I hope our Crew 10 mission becomes one of the best models of that cooperation. We've been training together more than a year. I believe we can be very successful in our goals and build a closer friendship among all of us. And of course, most importantly, have a lot of fun together. While we are on board the ISS, we are going to perform a lot of scientific experiments, including some medical experiments to better understand our bodies and for future space exploration. Our ultimate goal is to go to Mars, but it's not an easy journey, and when we face a new challenge, we must solve it step by step. Continue pushing the boundary of possibility makes us gain new skills and also enhance our experiences. What I like about the International Station program is each country brings its own strengths. It's like a patchwork quilt. Each country is just one patch. Putting all the patches together creates one beautiful quilt that is ISS.
We now know a bit more about the astronaut who will be answering our questions. But who will be asking the questions here in TU Dublin? And how did our students prepare for this contact? 12 students have been selected from 9 of the primary schools we work with as part of the Tri5 Plus program. These schools are Stanhope Primary, St Gabriel's, St Paul's Primary, Scolmoire, Sacred Heart Killinarden, Paradise Place Educate Together, Christ the King Boys, Christ the King Girls, and St Philip's Primary. The selected students from these schools will have the opportunity to talk live with Commander Takuya Onishi aboard the space station. Tri5 is an outreach initiative funded by TU Dublin, Research Ireland, the Department of Education and Skills, ESERO and Workday, which delivers a series of hands-on workshops themed around space science and exploration to 4th class pupils. Aligning with the Irish primary school curriculum, this initiative encourages project-based and hands-on learning among the students. The program is designed to foster curiosity and confidence in STEAM subjects, encouraging children to see science and technology as accessible and exciting. As part of Tri5, the students have prepared thoroughly by learning to think like scientists, understanding how ecosystems can help us develop life support systems in space, learning how to build electronic circuits, and how to use wind turbines to generate electricity. They have even learned how to make and launch their own rockets, and they have also put all their knowledge to practice in order to design their own moon bases. But let's have a look at what they have accomplished in just 1 year.
and just seeing what you work with to get here. It's fantastic, and it's just, you're all so welcome today. No, it's okay, thank you. I think Space Fest is just the most amazing initiative, and just the excitement of watching that dot approach Ireland is just fantastic. But it's all about fun while you're learning. And for the next few days, the campus here will be a playground for the imagination of lots of young people like yourselves. And we're just delighted to have you here, where over the next few days, you can explore rockets, you can try a bit of computer coding, you can build rovers, and even do some art around different space themes. So there's something here for everybody. And if I get a chance, I'll be back over with the rovers and stuff later myself. But very best of luck to our 12 lucky pupils here today. I know you've got your questions ready, and I'm sure you're nervous, but I'm sure they'll be really, really nice to you as the space station flies over at 27,000 kilometers an hour, which is just fantastic. So that's faster than anything really on Earth, any car or plane. Here in TU Dublin, I think we're all around this learning by fun and reaching out to people and making sure everybody gets an opportunity. I've no doubt that some of you will grow up to be astronauts or engineers or artists or inventors of something really cool, even cooler than what we have here today. And I suppose that the main message I'd have for you, everyone has the potential to grow up to be, you know, whatever you dream you want to be. You're at college today, so going to college is no big deal after today. You're already here. So dream big, think about what you really, really want to do in life. I never thought I'd be here. I never thought I'd be a president, but it happened, you know, because I went after it and I really wanted to do it. And this wouldn't be possible really without the work of the staff here, people like Seamus, our access and outreach team, the teachers, the families, our friends at ARIS, Workday, and all the schools that we work with. So I think reach for the stars. Maybe one day you'll work amongst them, like our astronaut who's hopefully still approaching Ireland. So thank you very much. Thank you.
Thank you very much, Deirdre. Right, so we'll pass it back again to Seamus. So we are now around 20 minutes from acquisition of signal, which if my colleagues can show us a map very quickly, we can tell you what it is. So if you can see, as we said in the video as well, around the ISS there is a circle. When that circle overlaps with the cross in Ireland, which marks the position of our station, that means that we will be in reach of the radio signal. So that's when we can start calling. But in the meantime, nobody better than Seamus here, who has been working in ARIS for years and years and years, and has gotten us this second contact in Technological University, to tell you a bit more about this.
Okay, I just want to say a few words about the people that are here today, and thank you first, Dr. Lillis, for coming along and for those words of encouragement and indeed of foresight, because some of these we all hope will become, as you rightly said, the scientists, the computer scientists, the engineers, or indeed the artists of the future. I have a great team here. Of course, there's Anna, whom you've all seen, and she has worked really, really hard to make all this have happened. And there's a man standing there with his arms folded, and that's Robbie. And Robbie has built the radio station that is here, and we have every confidence in Robbie. Yeah. But, you know, and beside him is Dan, who's in charge of the backup station. And beside them is Vic, who is monitoring the channel to make sure that it is clear. And then we have the guys from DV4 who have given their time freely and voluntarily to put together all the audio and all the streaming and all the video. And standing there with his finger to his mouth is John, who has done Trojan work with liaising with all the various people and making sure that this would happen on time. And he's going to wave at me at some point and tell me to shut up. That's what I'm under. ARIS, as Anna already said, are a group of amateur radio volunteers that have come together with some people from NASA. The astronauts that we talk to are astronauts who have volunteered. They're doing this in their spare time. They don't have to go into the amateur radio program if they don't want to. And they do this so that they can spread the message of technology, of science, of indeed art and the arts to young people like yourselves throughout the world. So it really is, you know, a great project. And, you know, tonight, unfortunately, well, not unfortunately, but after this, when you guys are all in your beds, I have to go to a meeting and tell them all. I will tell people from America, from NASA, from the United States, from Australia, from Japan, from Belgium, Germany, Italy, France. I will be talking to them all and telling them how this went. I will also be telling them how you guys practiced so well and so much. I told you that at the beginning when we met. We were going to practice and practice, because it's like anything. The only way you will learn is if you practice, and it's true for this. And I know it's just going to go really well. It is, of course, an experiment. This isn't commercial equipment in that sense. This is, you know, Robbie's own radios and Robbie's own antenna that we've put on the roof of the building. And, you know, there is an element of, shall we say, uncertainty about it, but I'm pretty confident, and you're pretty confident, Robbie, aren't you? Yeah. Okay, you know, it all started when I was about your age, in 1957, so you can do some math. It all started when the then Soviet Union launched the first artificial satellite that went around the Earth, and I actually remember going out to look at it with my father. But now, of course, we have the ISS. And Anna's already told us a lot about the ISS, so I'm not going to really repeat all of that. But the other problem is I've got to keep talking. So that's life. Now, it has various modules, and Anna mentioned the Columbus module, and there's an amateur radio transmitter in the Columbus module. There's also the Russian module, which is called Zvezda, and Zvezda means star. So they also have there an amateur radio transmitter, and it's used by everybody on board the station. And those of you who were here earlier might have heard the strange noises coming. That was it sending telemetry data down from the ISS. And we listened to that so that we could check our antenna and see how well it was working. And there's a photo. It's a little bit old at this stage, but there's the radio embedded among all the hardware and the pipes and the wires in the Columbus module. Now, I have a bee in my bonnet about this, and I showed you guys when we started talking an earlier version of this photo, but this is the current photo. They have a big parking problem up at the ISS. It's worse than trying to park down the road. Now, the only thing is there are no parking wardens, so nothing happens. And at the moment, there are 5 space ships docked with the ISS. 3 of them are cargo. Somebody has to send up all the food to the ISS so that the astronauts and the cosmonauts can eat. And the other 2, the Crew Dragon 10 and the Soyuz, are transport spaceships. Now, the interesting thing is they also serve another purpose, in that the ISS has no motors or engines, and every so often it needs to move. It needs to change its position, because maybe there's a bit of space debris, or maybe its orbit has decayed just that little bit. And so they use the thrusters, the engines on board these docked spacecraft. They use those to correct the position of the ISS. Now, that's happened a few times in the last few days, because originally we thought this contact would be at 7 minutes past 12 UTC, which is 7 minutes past 1, but now it will be about 11 minutes past 1. And Robbie spent a good bit of time this morning making sure that he had fed the right information into his tracking program and into this program here. There are 7 crew there at the moment, and they come from 3 different space agencies. 3 are from NASA, 3 are from Roscosmos, the Russian space agency, and 1 is for JAXA, the Japanese space agency. And that's who we will talk to today. We will talk to Takuya Onishi, who is the commander of the ISS. Now, to put it in simple English, he's the big cheese now. And he is taking time, guys, voluntarily to come and talk to you. And I hope you will remember it, so that when you get to my age, you will remember the day you sat here in TU Dublin and you talked to the commander of the International Space Station. This is a block diagram, and you probably need to look at it on the internet, but it shows you how the radio station that Robbie set up works. What I want to say is that everything is duplicated. So if anything goes wrong, we can switch to a different antenna, we can switch to a different radio. And that's why Dan is sitting there, and he will help with that changeover so that we don't miss this wonderful opportunity to talk to the ISS. Because the ISS is a bit like a bus, in a sense, coming along. If you're not paying attention and you don't put your hand out, the bus won't stop. It's just going to go past, and there's nothing we can do about it. So if we're not focused well on it, we're going to have trouble. Now, Anna did this in graphics, which is much better than I can do it here. And these are the orbital planes. Sometimes satellites go around the equator. And there are lots of those, and they're the ones that give you TV. They're the ones that you use for satellite television. And because they go around the equator at the same speed as the Earth, at the same angular velocity as the Earth, they appear to stay steady in the sky. So they are geostationary satellites. Then there are other satellites that go up and down from north to south, and the Earth moves underneath them. And they are used for weather. They are weather satellites. And you get pictures from them for weather. And it allows meteorologists to keep an eye on the weather. And then there's all the other satellites, and they're in an inclined orbit. And the inclined orbit for the ISS is 51 degrees. Now, that means it will never go overhead us here in Dublin, because we are at 53 degrees. But the advantage of that is that our antenna won't have to point up, and so it won't be moving really quickly. It'll be moving relatively slowly along the horizon. Now, the highest it'll get today is about 30 degrees above the horizon. So from our point of view, it should be relatively easy to track. But of course, as I said, this is an experiment. And there is another complication. Robbie is not just going to be sitting there looking at his dials, because I don't know if you've ever listened to a train, coming at you very quickly. And it goes, whew, like that. It sounds very high in pitch as it comes towards you, and the pitch drops off as it goes away from you. And that's a thing called the Doppler effect. And that means that the signal that's coming from the ISS will be varying, and all the time Robbie will be retuning his radio so as to keep it accurately tuned to the signal from the ISS. Now, this is our tracking program, and as again you saw, it has the track that the ISS is going to take. There's a few other tracks there. They're the ones that will happen later in that day. I removed them from the active map. And you can see the circle around the ISS, and as Anna pointed out, when that goes through the cross, we know that we're within range of the ISS. There's also other information there which will tell us what angle it is at looking out, what angle it is at looking up and down, and it will also give us a value for this Doppler shift. So, you know, it's relatively complex, but I keep saying it, I know Robbie will deal with that. Now, Robbie, have I embarrassed you enough? No, I haven't, right. No pressure. There's no pressure in this at all. And here is a picture of the astronaut we'll be talking to, Commander Takuya Onishi. And I'm sure we will hear him in a matter of 10 minutes or so. 8 minutes. Right, I need to wear my glasses. I need to keep talking. Okay, well that's not a problem. So, are we all very excited? And we're nervous, right? And we all remember the word I taught you the last day. No. Cod is brí leis an bhocal túnas. We must be very quiet as mice. Anna designed that. She's, apart from everything else, she's very good at design, and that's a cat, because Anna has 4 cats. Don't you, Anna? I do. And I have 1 cat. And my cat, I call him Dylan the Terminator. So remember, tune us now when this is happening. Okay? So, where are we here? I'm going to step over here out of this picture. And you can see that the ISS is now just passing over the northern edge of South America, right? And we have 11 minutes and 51 seconds, according to that, to go until it's within range, right? And you see where it says Aris voice, it says 1458030. That should be 8000, but because it's coming at us, the pitch is higher, and so it's 803. So Robbie will have 803. Well, it won't be that when it gets nearer, but he will have that programmed into the radio. Right? Just get a feel for it. It's 7,000 kilometers away, and it's at a height of 418 kilometers above the Earth. Right? So that's where we are there. Robbie, I think we need to test the transmitter to make sure all is okay, please. Now, Joe's job in this is to turn the transmitter on and off. So that means that Robbie can focus on all his dials and Anna can focus on you guys asking the questions. So can we just have a short burst, Robbie? Okay, you happy with everything? Now that noise you hear is just static noise, right? We normally keep it dampened down, but when it comes to talking, we will let it appear, because if we dampen it down too far and the signal is weak, we may miss the signal. So it will be a little bit noisy. I'm on 1. I'm on microphone 1, Robbie. Okay. All good? And Vic has a remote station that's up at Stepaside. Thank you, Dan. That's up at Stepaside, so he can listen to our signals from a distance. One of the great developments that we have nowadays, in my day, if you wanted to have a radio, you got a soldering iron and you got a pair of wire cutters and you put all the pieces down and you built a radio. Now, a lot of radios are what are called software-defined radios. They are simply pieces of software that run on maybe a PC or a Mac or some dedicated type of computer. And they can be accessed remotely. And so it means that Vic can sit here and keep an eye on the signal that is being received up in Stepaside. It also allows him, because he has a display, to see any other signals that are near to ours. None of this was around when I was your age, guys. And there's been massive, massive changes in technology in a period of my lifetime. And I often would wonder what it will be like in the period of your lifetime. Quite definitely, by then, people will have gone to Mars. I don't think there's any question about that. People, of course, as you know, I remember sitting up one night watching them land on the moon. And there was what my daughter described as colourless television then, because there was no colour from television. But there will be Mars. There will be amateur radio on Mars. There will be amateur radio around the far side of the moon. Because Sputnik was in 1957, and 4 years later, the first amateur radio satellite called Oscar, orbital satellite carrying amateur radio, was launched. And it went round the Earth, and it kept sending out the letters H and the letters I. It kept saying hi in Morse code. And that was only 4 years after the first ever man-made satellite orbited the Earth. So radio amateurs have been very involved in space communication. I think, Dan, your name went into space, didn't it? Your name went into space, Dan. Yes, because our colleagues at the sister university, University College Dublin, launched the AirSat satellite. And Dan was contributing to that. And so they put his name on a plaque that's tied on to that satellite. So it's nice to know. And, you know, when we think of satellites, they're not big things. I mean, Sputnik was the size of a basketball, and it had these big, long antennas out of it. Nowadays, we have CubeSats. They're 10 centimeters by 10 centimeters by 10 centimeters cubed. Now, the UCD one is what's called a 3U cube, is 30 centimeters by 10 by 10. But it's still only a little box, right? And as I explained to you already, the first Oscar was a kind of a square-looking rectangle thing, because there is no air in space, so there's nothing to drag, there's nothing to slow it down. So the shape doesn't matter. The other thing that doesn't matter is the mass of it, what we would colloquially call the weight of it. That doesn't affect it. The equations for it orbiting the Earth are based on its speed. So it doesn't matter whether it's a little CubeSat or a big ISS, they will still orbit, for a given speed, they will still orbit at the same height. It's all a wonderful world, and I'm sure you will learn about it. I'm sure you already do, because I know my grandchildren keep telling me things. Do you know Grandad? Anyway. Will I sing a song?
No, that's okay. I can take it over.
You take it.
Thank you, Seamus. So we went a bit ahead of the schedule, and this is why we're trying to fill a bit of time. So we are 4 minutes and 25 seconds from the expected time of acquisition of signal. And as Seamus said, originally our contract was programmed for 13:06, and then because of the reboost maneuvers of the ISS, that had to be changed. So the ISS has to go up sometimes because of the orbital decay, because it kind of keeps getting closer to Earth, and they have to bring it up, or sometimes to avoid debris, spatial debris, which is one of the problems that we have at the moment. So that changed the orbit of the ISS and made the ISS arrive a bit later in here, like in range of the antennas. So we are 3 minutes 40 seconds. So I'm just going to double check. We have Wojciech ready, Lucy ready, Alfie ready, ready, Leon, Sosha, yes, yes. Josh ready? Yes? Everybody ready? Perfect. So all of our speakers are ready to answer questions. And what we'll do now in a second is when the circles start getting closer to us, we will start calling for the ISS and we'll wait. It is likely that we're not going to get it on the first few tries, but we always try and call ahead, because sometimes we can bend the signal a tiny bit and we can acquire the signal a bit faster. And that allows to us more questions. Now, we have 22 questions and we have 12 speakers. So ideally, they all have time to answer one question, and then the rest will be a bonus. So when we introduce, when we call Commander Onishi, I'll be calling, or this station call sign, which is Echo India 1, India Sierra Sierra, to their call sign in the station, which is Oscar Romeo, number 4, India Sierra Sierra. Okay, Oscar Romeo 4, India Sierra Sierra is what I will be calling. And we're getting very close now, 2 minutes 20 seconds. And then when we call, I'll say over, and then we'll hear that sound that Robbie let us hear before, the static. And sometimes through the static, we will be able to hear the voice come through. 2 minutes, okay. So we're almost there. Radio 1, right? Happy with it? Yeah. Radio 2, okay? Yes. Uplink, okay? And video, okay? All right. Okay, so Seamus will get ready now with his cues, in case anybody speaks. And they will let me know when we can call. So I'm going to get Wojciech here, just beside me. Because this is a game of speed. We try and compete to see how many questions we can get through. Are you nervous? Kind of. I am nervous. I forgot to say over. So it's 1 minute to acquisition of signal, and we call that AOS. Okay, Seamus? Yeah, we're going to start calling just in case. So Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Do you copy? Over. Now we don't expect to hear them. We don't expect to hear them because they're still not there. So we're going to call again. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Do you copy? Over. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Do you copy? Over. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. Do you copy? Over. Welcome to University Dublin, Commander Onishi. This is Echo India 1, India Sierra Sierra in Technological University. We copy you not so well at the moment, like a 3 and a 9. How do you copy us? Over? Echo India 1, India Sierra Sierra returning. Commander Onishi, this is Anna in Technological University Dublin. We don't hear you clearly just yet. How do you copy us? Over. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. We are losing your signal. How do you copy? Over. Oscar Romeo 4, India Sierra Sierra. This is Echo India 1, India Sierra Sierra. We're still not receiving you well. We're just double checking our system. Can you let us know how do you copy? Over.
Hello, I can hear you loud and clear. Welcome on board the International Space Station. Over.
Thank you so much. This is Anna in Technological University Dublin. We hear you loud and clear now. Are you ready for questions? Over.
What is the most challenging part of your day as an astronaut? Over.
Well, for me, it's getting behind of my schedule on the ISS because our schedule is so packed, and once we get behind, it is sometimes very difficult to catch up. Thank you for the question. Over.
Do your eyes get dry in space? Over.
Gravity, small particles and dust tend to float in air and get into my eyes. So my eyes. Thank you for the question.
Is it lonely to be so far away from home? Over.
It's not so bad. Thanks to the technology we have now, we can do video chat and also make up or do email with our families and friends, so we can still keep in touch with them. And so it is not so lonely to be here. Thank you for the question. Over.
What is it like to sneeze in space? Over.
That's a very unique question, but I don't think there is any difference between in space and on the ground. We sneeze just like you do on the ground. Thank you for the question. Over.
What inspired you to be an astronaut? Over.
I am a big fan of Star Wars movie series since my childhood, so I have been dreaming of going to space all the time. Thank you for the question. Over.
What has been your greatest scientific discovery on the ISS? Over.
Well, I have been working on an experiment called ELF, E-L-F. It's a very cool experiment of material science. It heats up materials up to a couple of thousand degrees Celsius to measure their characteristics at high temperature, which we cannot measure on the ground. So I think that it's a very cool. Thank you for the question. Over.
How do you get your oxygen in the ISS? Over.
We have a device called oxygen generation system, which produces oxygen from water. We also have some oxygen tanks in the generation system there.
Are you able to have tea in space? Over.
How do you know if you're upside down? Over.
How to orient our bodies. The question over.
Do you have any advice for kids who wants to be an astronaut when they grow up? Over.
Well, mine from my own experiences is to work really hard on something you don't like or you are not good at. Because you can learn so many things from those skills and they will help you to enhance your
Is the ISS automatic or do you actually have to pilot it? Over.
Complicated structure that we cannot pilot it by ourselves. The ground teams are actually flying ISS remotely. Thank you for the question, over.
What does space smell like? Over.
Are there germs in space? Over.
Over.
Are there germs in space? Over.
The ISS is a very clean environment, but I'm sure there are some germs. Before launch, we spent 2 weeks in quarantine in order to prevent delivering germs from us. However, I think it's almost impossible to shut out all germs. Thank you for the great question. Over.
Does it get cold in the ISS or do you have heating? Over.
I'm sorry, I can't hear your question. Can you say that again?
Does it get cold in the ISS or do you have heating? Over.
Okay, I copy the question and the answer is yes. We have heaters to prevent the ISS structure from getting too cold. On the other hand, there are many pieces of equipment which generate heat inside the ISS. So we also have air conditioning system to get some cooling here. Thank you for the question. Over.
How do you know when to go to sleep? Over.
This is a great question. The ISS orbits around the Earth 16 times a day, so you cannot tell if it's daytime or night by looking outside. We totally rely on our clocks or watches to get to know what time it is now. And when we go to sleep depends on the individual, but I typically go to bed between 10 p.m. and 11 p.m. Over.
Thank you so much for answering our questions, Commander Onishi. We are now nearing loss of signal, so we wouldn't like to stop this contact without being able to say thank you and give you a big round of applause. Over.
Thank you very much for those great questions. Really enjoyed talking with you today. Thank you so much. Bye-bye.
73, over and out.
Thank you very much. Bye-bye. Over.
There you you go. So congratulations, everybody. As you can see, this is an experimental sort of endeavor. And sometimes, even with our best intentions, even with our antennas having been tested thoroughly in the past few weeks, we can still have trouble contacting the ISS. But we were able to get through most of the questions, so I think we should be quite happy with it. And now, thank you everybody for watching. And before we continue, I'd like to pass the microphone again to Dr. Lillis, the President of Technological University Dublin, so she can do some closing words. Thank you so much.
Thanks, Anna, and amazing. In fairness, big sigh of relief, I'm sure, to all the technologists back there. And I think it's just what's just happened from a technological perspective is just massive, in fairness. And I think the questions you guys came up with were just brilliant. There's things that I hadn't thought about at all. So that was just one of the best things I've ever done anyway. And well done to everybody, because I can just see the strength of the team that has had to go into putting this together. It's part of the Space Fest 2025, supported by our partners Workday. And again, you know, we can't do this without collaborations and partnerships. It's also an extension of Try5+. This is an initiative funded by Taija Éireann, Research Ireland, the European Space Education Resource Office and the Department of Education and Skills, all about inspiring primary school students to explore and engage with STEM and STEAM, and around this exciting theme of space. And just a big congratulations to our own team in the Access and Outreach Office for organising Space Fest, and our amazing partners at IRIS and the amateur radio community for facilitating the call today. So thank you so much. That was just fabulous, in fairness. So, and well done, Anna. That was high pressure all around, and just delivered spectacularly. So well done. Thanks.
Thank you so much. And as Dr. Lillis said, this couldn't have been possible without the ARIS, the amateur radio in the space station, and the radio amateur community that we have in Ireland, who, when I got kind of contacted to see could we do another ISS contact, they jump on board like really, really quickly and have been working tirelessly. When I requested them, taking their own like annual leave and their holidays to be able to help me and help us all accomplish this. So I'd like to introduce, as part of the main body that kind of represents radio amateurs in Ireland, the president of the Irish Radio Transmitter Society, IRTS, John Kelly. Echo India 4 Lima.
Thank you, Anna, and thank you to everyone. I think I get the easy job looking at all the pressure that was around here this afternoon. What a fantastic experience. It's an inspiring event here to witness. This is my first live event. The last couple of ones I streamed at home and listened to the ISS myself on my own radio. On behalf of the Society, I'd just like to say how proud we are of our members who've supported this event today. Seamus mentioned everybody, which has made my job a little bit easier because I'm always afraid that I leave somebody out, so he covered everyone. They're all around you, some you see, some you don't. There's a lot of work went into this over the last number of days and weeks, and the preparation to get an event like this is actually mind-blowing. We are very proud to have supported it, and it's an incredible link here for the students to contact the space station. Well, what an experience for you guys. It's absolutely amazing. For many decades, amateur radio is not just about communication. It's about building bridges, fostering curiosity, and encouraging the next generation to explore science, technology, and innovation outside the standard educational system. Seamus mentioned his journey into amateur radio. I, a little bit later, not that much later, had a similar journey through a family. My grandfather was a licensed ham radio operator back in the 60s and 70s. Today's contact is a powerful reminder of what simple technology can actually still do. It looks very complicated here. We've got lots of cables, we've got live feeds, we've got radios, but in essence, it's a radio and an antenna, or better known maybe to some of you as an aerial, and that's it. It's a simple 5-minute contact using technology that's been around quite a while. We did have the advantage of tracking systems and tracking software, but in essence, there are times where you can just go stand out, put your hand up and hope that something will happen. But we couldn't obviously do that today because we had so many people here, we had to do it properly. But it's a triumph and it's contact. In this day and age of, you know, the world where it is, it's great to see a number of nations still united in a common quest and in space exploration. We are honoured in the IRTS to be part of the programme. It's a project that embodies the best values of collaboration, learning and outreach. And none of this would have been successful without our volunteers who were mentioned earlier and our ARISS mentor Seamus and the team of volunteers behind him. These individuals have given their free time and their expertise to ensure that the students today had a fantastic experience. To the students, you've not just spoken to space, you've demonstrated what happens when talent, teamwork, technology come together. I hope it sparks an everlasting interest in space, science and technology, and even amateur radio, which we'd most welcome you to. Remember that the skills you've learned today throughout this year in Tri5+ and the skills you've seen in action, questioning, problem solving, communication, collaboration and confidence are life skills that you can learn and bring with you in any field. Finally, I want to thank TU Dublin for your leadership and hospitality, and our colleagues again for making this a reality. Congratulations to everybody involved. I would now like to pass the microphone to Dr. Patricia Moore.
Thank you, John and Dr. Lillis, for the welcome invitation. My name is Patricia Moore, and I'm a director and co-founder of the Irish Space Association. And wow, what a privilege it is to be here today with you all to make live contact with the ISS. You know, 400 kilometres up in the air, travelling at 28,000 kilometres per hour, and to be able to talk directly to the commander of the ISS is just an amazing achievement. And that would not be possible without all the amateur radio folk here today. So thank you for monitoring and tracking the ISS with such precision to allow everyone to ask their questions and to hear the commander give his answers so clearly for the most part. What struck me most about today, apart from the technological achievement, is actually who made the contact. Deaf schools from all over Dublin preparing questions and getting that opportunity to speak with the commander of the ISS is just amazing. And it gives us a glimpse as to what's possible, I suppose, when access and opportunity meets with the passionate communities who are willing to stand up and make things happen. And events like today are a great success and a great testament to that. Today, in the industry speak, we talk about the democratization of space, and that's the industry speak at the moment. And the democratization of space is really a fancy term for, greater access and greater opportunity by extension. And, just like you guys had greater access and opportunity today, that access and opportunity actually allows smaller countries like Ireland to be able to participate meaningfully in the global space economy. And that's an economy that's expected to triple over the next decade. So it's really important. And why does that matter? We've 100 companies, more than 100 companies actively engaged on European Space Agency contracts, enabling them to develop world-class and in some cases world-leading capabilities. And we face a lot of global challenges at the moment, and space gives us the opportunity to monitor things like how our planet is changing, climate change, increased connectivity between people, and even advanced medical research, as we saw in the video today. So space is really important in everybody's daily life. And today we've really seen what's possible when we commit to closing those opportunity gaps, not just in space, but right here at home. So to the students today, wow, your questions were insightful, intelligent, thoughtful. I'm sure there were some questions in there that the astronauts haven't heard before. And I really hope, I suppose, my hope for you today is that you take that curiosity forward and keep being brave and keep asking those questions. And I have great confidence that I've seen, future leaders in the space sector emerging from classrooms just like yours today. So a really exciting time for the sector. It often comes as a surprise that Ireland has such heritage in space. But today we're actually celebrating a lot of serious milestones and anniversaries. So Newgrange was founded 5,225 years ago this year, which is an amazing thing. And its alignment with the winter solstice means that it's actually one of the oldest observatories in the world, if not the oldest. Another big event this year is we're celebrating 50 years of the European Space Agency. And not many people would know this, but Ireland was actually a founding member of the European Space Agency. And later this year, we'll be celebrating, as Seamus mentioned earlier, the launch of AirSat-1, which was Ireland's first satellite. So we can participate meaningfully in the global space race. And let's not forget that there was lots of Irish notable figures who paved that way and continue to lead the way in the space sector. Too many to mention here today, but it's important to point out that the people who contributed came from all walks of life, from various backgrounds. So I'm conscious that I'm keeping everybody from their lunch. So thank you again to TUD and to the team of amateur engineers who, got us in touch with the ISS today. And on behalf of everyone in the space industry, we're just really thankful that we can see the next generation of leaders of the space sector emerging today. Thank you.
Thank you so much, everybody. So we'll now come to a close. And just before we cut the stream, I just wanted to give another thank you round. First to Seamus, our radio mentor, who attends every meeting of ARIS in his own time and fights for us, for Ireland, to try and get us this type of life-changing activities. And my fantastic colleagues in the IRTS and the General Radio Amateurs of Ireland, and especially Robbie, Co-India 2, India Papa, because he has provided us with the equipment and the antennas, and he has brought everything from all the way from Limerick. Dan, for keeping track of the backup station. Joe, for keeping us on track with the PTT button. Vicky here checking that there is no interference in the uplink. And then we have John, who has coordinated all of the media and the streaming. And we couldn't forget our friends from DD4, who have been in charge of this whole streaming endeavor. They have done it for free, and they have dedicated so much time and effort and expertise to make sure that you could watch this event live for us, and that other people can then have this activity recorded to learn from it. And finally, I need to thank TU Dublin and my fantastic team in Access and Outreach, because how passionate they are, all of them, and how they always agree to these crazy activities, like doing another contact with the ISS, despite the time constraints that we have. So thank you so much, everybody, and all of you that are watching as well. Thank you for being here with us, and 73.